Okay, cool. Let's go.
Welcome to the current BoF.
Yay. Ah, good morning, everybody. How is everybody today after the long day trips?
Happier.
Sure. You may remember me from such previous BoFs as the ON BoF 2018 and the ON BoF 2017 and so on. Let's just have the usual catch up, see what we're doing, see what the ports are looking like at the moment. I'm going to talk about build Ds and hardware because we do have updates compared to last time. I'm sure there's plenty of other things people would like to talk about. This is a BoF. I'm going to make this point again, like I always do. This is not just a session for you to sit there and let me lull you to sleep. Please talk to me, and also please take notes. I've just set up the Gobby document. I will do my utmost, as always, to send a summary of any discussion to the mailing list afterwards. I think that's a really important thing because there are many more people interested in Debian and ARM than just the 24 people in the room. So, quick rundown. ARM64 is a current port. We first released it with Jesse, and wow, that feels a long time ago now. It's working really well. Many more devices are available now, and of course there are more coming because, hell, there are so many manufacturers doing ARM devices these days. We have real server hardware. I will more on that later. We have a simple choice of kernel for ARM64. We're using either device tree blobs or ACP to describe the hardware. There are all kinds of machines out there that the chances are will work with the current kernel, even if they might be released after the kernel has been released. Such is the power of a reasonable generic hardware description. It's really good. We have ARMHF. Again, its current port, first released with Wheezy. Hands up, who knows what VFP v3 D16 means? I'm not going to. I appreciate it's morning. I'm not going to push too far. Basically, it's a hard float ABI for V7 with a specific minimum requirement on the floating point unit, which basically, give or take, almost every V7 device supports, and that is important for us. Modulo the occasional insane devices that don't have floating point, just about every V7 device will work with this. We do not mandate Neon, for example, because there are still quite a number of devices out there in common use that do not have it, and we don't want to be excluding people. If you have specific needs for SIMD or for lots and lots of floating point stuff, then by all means you can use it, but you should be selecting it at runtime or through a different set of packages and not by just assuming it for everything you build for ARMHF. This does cause problems and has caused problems on our build Ds even, so don't do it. Again, we have a massive set of supported devices. We have a choice of 2 kernels for ARMHF. Again, with DTBs, that does come out to a massive set of devices. The only choice about supporting with the 2 kernels is one has LPAE, so if you have more than 4 gigs of memory, you can actually use it.
Is it worth to note that our ARM infrastructure doesn't support Neon, and some packages enable Neon test suites, and those face on the build daemons, but maybe we have another machine with Neon, and that might work, the test suite on that. But so we don't. If you run Neon instruction set on your packages, it won't build on our current build daemons. So
sure,
it's just worth noting that.
Yeah, thank you. Or in fact, on some of our current build daemons, some of them do have Neon, some of them don't.
Is that something that we can set a default test for to actually look for these sort of things as part of the building process?
Not easily. It's something people need to be aware of when building their packages for when setting up their packages for building. The last thing I want to touch on here is finally, with Buster, we have support for UEFI with ARMHF. Not many native ARM-HF devices actually do UEFI sensibly, but it's growing. In particular, as Vagrant well knows, current and recent versions of U-Boot have included support for basic UEFI. That doesn't mean that you have all of the extra overhead of, say, running EDK2, but it does mean that you can actually have a reasonably sensible set of interfaces, so you can boot using our normal mechanisms, using, in fact, our CDs and USB sticks and SD cards and whatever direct, in theory, without having to fight with things. The other bonus of this is something that DSA wanted for a long time. We can now have 32-bit ARM-HF VMs running sensibly on our ARM64 machines. More on that later. So, the oldest of our current ports, ARM-EL, first released with Lenny, so many years ago. It's a soft float ABI, used to target V4T, it's now V5TE. We did lose support for some really old devices by making that move. But we are now not quite so far behind the curve in terms of compiler support and bits and pieces like that. It is still upstream supported in most languages. There are some that have needed quite a lot of effort, but ARM v5 is still such a large target market, and apparently also for lots and lots of companies doing their own embedded things, that while we were talking about dropping this maybe for Buster, we decided not to. Lots of other people have worked on this. If this is genuinely important to you, please make your voice heard on the Debian ARM list and chip in effort, because that's the way to make sure that this will continue to be around for Bullseye, Bookworm, and whatever B comes after that.
Especially on the put in effort part.
Yes, exactly. Putting in effort.
On the mailing list.
Yeah.
Especially on the putting in effort, how talking on the mailing list actually kind of detracts from it unless you're including effort.
Yeah, I mean, I'll be brutally honest, we don't necessarily need a lot of ongoing effort on this, but the more people putting effort in, the more likely the port will survive in the long term. So, build decent hardware. So far for the ARM32 ports, we are still relying on some 32-bit machines, which are dev boards. We have a load of the Marvell Armada XP V7s, and again, these are special in that they don't support Neon, hence it really matters to us about the choice of your floating point setup. And we still have a really, really old IMX53 porter box, specifically still around because it does include Neon and it's V7. It's Cortex A8. That's one of a set of machines that at one point we did use to bootstrap ARM-HF with, and it still works flawlessly, but it really is, it's a little like 3-inch by 3-inch dev board with a hard drive attached. Lovely machine, but oh my God, does it feel slow these days. ARM64 gives us a much wider range of machines. Listing here just some of the available recognizable machines. Some of these you can't buy anymore, some of these you can. We got Seattle, XGene, Thunder X, Thunder X2, Macchiato, the Centrique, the Synquesa. A new entry here is the Taishan, which is a Huawei machine that I'm hoping we're going to be using more of in the coming years. We have decided to move away from using those dev boards for building our 32-bit ports. Basically, DSA, the Debian sysadmins, are bored of fighting with the problems that come with dev boards, and I totally and utterly understand that. Speaking as a person who often ends up having to go into the machine room at ARM to go and push buttons and reset things because you can't do it remotely, it really is a pain. The other problem with dev boards is they typically only have support for one disk device. So when the hard drive or SSD that's attached dies, it's a reinstall, start again. So we've decided to move away to using the ARM64 server-based machines, which have, all of the normal things that you want on a server, like multiple disks, lots of memory, in most cases stuff like remote power, remote management, that make it massively easier to keep supporting these. Oh, and also they fit in a rack instead of needing to be taped down to a shelf, that kind of thing. Most of the ARM64 machines I just mentioned will run 32-bit binaries natively, but not all of them.
Oh, so will we introduce a problem where we accidentally make ARM-HF support Neon as a result of doing this?
Maybe. And that's a very good question. It's something that we've had to think about in the past when we were building our V4 and V5 ports using V7 hardware, that it's actually it's something we hope we won't trigger because our compiler setup should do the right thing, but it is always possible that we might end up leaking some setup from the host machine into the builds, and it does cause problems. Hector?
Would it make sense this is an open question, would it make sense to default to Neon?
No, definitely not. There are many people out there still running with hardware that cannot do Neon. Why should we throw those people under the bus? In particular, for example, the Scaleway machines. Scaleway, the ARM Cloud people have a lot of non-Neon V7 machines, and there's a lot of people making use of that. So, were you about to say something? Oh. So, most of the ARM64 machines we have at the moment will run A32. We're now seeing the very latest range of ARM server-based cores are slightly more nuanced than this. So, for example, the Cortex A76, which is used in the Taishan I mentioned just a few minutes ago, will run A32 binaries, but only at EL0, so in user land. You can't have, actually, it might be EL1, but you definitely do not get EL2 for 32-bit binaries, so you cannot run a sensible 32-bit VM on that hardware. And these are all understandable decisions to take. Many of the server vendors don't care about running all 32-bit binaries. It's not something that they ever cared about with their architecture. If you leave out the decoder logic and all of the support for running the A32 binaries, you can fit more 64-bit only cores into the same die space. You get better efficiency and all of that. These are good decisions to take for them. It just sucks for us when we're looking for machines that will still run 32-bit binaries. So, of the machines I listed here, many of the older ones, of course, will still list both. So I'm suggesting that we might move our ARM64 builds onto the newest hardware and keep the older ARM64 machines around to run the VMs on and whatever. I think that makes sense. So I did do a rebuild last year, or two rebuilds of ARM-EL and ARM-HF on ARM64 to find out what issues we might find with doing this. I made a lot of noise about it, spoke to a lot of people. In the end, most of the archive just works. There's a small number of packages that break because they assume alignment things. Really, people, alignment should not be something that we have to be telling people about in 2019, but apparently, it's like it used to be all the world was a VAX and then all the world was a Sun. Now all the world is running on x86 and therefore, alignment doesn't matter. It really does. Even on x86, if you have badly aligned code, it runs slower. It's less efficient. But because the compiler and the platform let you get away with it, most people never notice and don't care. So we have found alignment problems. There were a few bits and pieces of mix-ups in our code. I found a few minor bits and pieces that mean that as we move forward to running the ARM32 builds on ARM64 hardware, we're going to be running those in VMs so that then we can have the kernel supplied fix-ups. So we can continue to run our old stable and old stable builds, and it'll all just work. As we move forwards, what I would like to do is not be running our 32-bit builds in VMs and actually run them natively, or just in churoots on the ARM64 hardware. We do get quite noticeably better performance that way in a lot of cases. It also means, of course, we can then use the newer, faster hardware. So, I did mention about real servers, didn't I? So these are two pictures of an unnamed machine that I had in the build from ARM just before I came out here. It looks boring, I appreciate. You can't really. There's not very much to see in the picture on the left. It's a 2U rack mount box. Who cares? Well, actually, I care a lot, because if you take the lid off and look inside, okay, you probably can't see very well from here. There's a pair of 48-core CPUs in those sockets. There are 16 DIMM slots. There is a BMC hung on the back. There is redundant power supply hardware, rather. There's space in the front for 12 disks. These are real machines that work like real computers, without us having to make excuses for, oh, well, it works most of the time, and every now and again Steve might have to go into the server room to go and push buttons. This is the kind of thing that you can put in a lights out data center and it just works.
And I believe we can actually order this and buy it as mere mortals.
There are also ways of buying this right now on the internet. You can go and buy a chassis today. So Doco asked about the price tag. I've seen suggestions, I don't know the exact details, that a chassis like this is like $2,500. It's not cheap, it's not typical home user money, but for the performance you get here with 96 cores and maybe half a terabyte of RAM available, that is reasonable ballpark compared to even cheap x86 machines, and its competitive performance. With 96 cores and lots of memory, we could build all of our ARM64 code on this in the one machine. The only reason we wouldn't do that is because we want to have redundancy. So, that's my wibbling and a few questions from people. What else should we be doing with our ARM ports? Does anybody have any comments, questions? Don't all shout at once. Andy?
Well, I just want to comment that as part of the release test weekends, it's really nice to just be able to stick a USB stick into bare metal, DI, just work, do secure boot-ish, and it's just like any other machine. This is now turning into a mature, usable architecture that anybody can pick up and use. It's no longer for the specialists.
Yeah, dare I say, it's getting boring in those senses. Where boring is good.
Hi, I think we should start supporting desktop and laptops, because, for example, this is the ARM64 laptop with Snapdragon, and it runs normal GNOME shell and everything.
Yeah.
And we should probably ship that as well.
Sure. That is definitely one of the things I want to do before Bullseye. So to give more details, this is the Lenovo Yoga C630, which is a Snapdragon CPU in the 8 gigs of RAM. How much storage? 256 gigs of storage. It's a machine that it's the first Lenovo ARM-powered machine, possibly of many. There are other vendors doing these as well. Genuinely, this is where a bunch of us wanted to be getting 5 years ago, and it's nice to see that we're not just seeing small hobbyist people doing this. This is one of the biggest computer vendors on the planet now selling a capable ARM64 machine. I think that's awesome.
Kind of on the other end of the spectrum, we now have supported in Buster a laptop you can use and install with Debian installer. So this is the Pinebook, the Olemex Terry's one also. not nearly as fancy hardware specs with 2 gigs of RAM. But, you know, you have video output, which is amazing. Wookie did some really cool work to get Debian installer to work on both the serial and the frame buffer console. So you can actually do a Debian installer install on ARM without needing a serial console, which is pretty exciting.
Minor thing is there are bugs that's introduced I need to fix, but yes, it is a really, really useful piece of work. Yeah. Oh, we've had a report that if you try and run with preceding, you end up with 2 installers running in parallel and it breaks. So we need to fix that. That's something, it's on my radar already to fix ASAP.
Right. And then the other reality is, like, you can get one of these with, like, all of the upgrades that are available for $150 US. I don't know where the Lenovo kicks in. $1 grand.
Yeah.
So we have a range of things.
Sure,
this is a
absolutely.
usable travel laptop that if you lost it, well, you wouldn't be out too much.
Yeah.
And that is a nice machine.
You know, again, it's similar to the x86 world. They're all really cheap machines that people can live with, all the way up to expensive, nice machines that professional developers will want to use as workstations. It will be really nice if ARM64 gets to just the same point.
Okay.
Hey.
The next question is that is the microphone on?
Yes.
Okay.
Yeah.
So if I buy on laptop like some laptop from ASUS, how easy is it to install a Debian in it?
It's not yet.
Okay.
Apologies. It's very much it's the beginning. So yeah, Dimitri will tell us more because he's been working on it directly.
So there are a couple of machines which there is a Linaro effort to enable. So like there is Lenovo MiX 630, HP Envy X2, and Asus Nova Go. All of them are, and there's also Samsung Galaxy Book 2 or something like that, right? All of them, we're trying to enable it in Linaro effort with a single image, such that you may need to select which model you have at boot time, but all of them kind of install with the same hack kernel from Mazda with patches, with DTBs and
So
kernel command line options and etc. So yeah. But in practice, like the images we try to produce, they're easy enough to use for regular people who want to put something in and install.
Yeah, hopefully by the time we get to Bullseye, we'll actually have our normal standard ARM64 image will recognize these and do the right thing, and it will apply, you know, all of what are currently hacks and bodges and special images will just be rolled in, so you won't even need to know about it.
Yeah, so for example, like the 5.3 kernel can boot with ACPI already with recognizing hard drive to complete the install offline, for example.
Cool.
Might be worth to talk about the graphics support. Things are improving in the ecosystem.
Oh, sure. Well, go on then.
Well, there's the Panfrost driver. There's putting a lot of effort for Mali support. I don't know.
Yeah.
I'm not sure which GPUs these machines you're using. And there's a wide range of graphics that now open. I'm not sure what's the current state in Debian, if we should put some effort to enable those and make it work nicely.
Yeah, we've had a range of issues with the embedded graphics in the ARM port over the years, with a whole range of different random non-free drivers, including from ARM, which were locked down as much as anything because of worries about patent trolls as because of any actual inherent problems in the drivers. Wookie did a load of work to at least get the official ARM Mali drivers into non-free, but now, yes, the Panfrost effort is starting to come out, so we should get, hopefully, good, properly free driver support for ARM machines, for ARM's own graphics hardware soon. There's a whole range of other people in this space where, again, they haven't actually had free drivers, but people have reverse engineered. It's all a bit of a mess. It would be nice if we actually just get good free drivers here, like we do on all the other platforms. We'll see.
I've kind of been wondering if we might explore doing live images for ARM-based systems.
Yes.
Especially with the EFI.
Yeah, absolutely.
That makes it a lot simpler.
Sure.
A little trickier if it requires U-boot, but not impossible.
Sure. Yep, it's a good call, and thank you for trailing that. At the moment in Debian, we only have live images for AMD64 and i386. I've been pushing that we should just give up on i386 because it's dead, and instead do ARM64, especially on the modern machines with plenty of memory and USB 3 hardware and whatever. There's no reason why we can't do the same thing.
I mean, on Ubuntu, we provide cloud images, which are live images,
Sure.
Ubuntu server live image, and desktop live image for all the arches. So,
Yes, but that's Ubuntu, not Debian.
I know. So it's doable.
Oh, it's perfectly doable.
No, it's doable,
Yes.
and it's actually useful. Like, people use it.
Yeah. It's very much part of the plan. We already have ARM64 OpenStack images, and as of a few days ago, ARM64 AWS images. There's no reason why we shouldn't be treating ARM64 as a first-class architecture in every respect in Debian. So that's coming. I'm sure, obviously, patches and help are welcome. There's another piece of work that I'm going to mention very briefly. I've already spoken about device tree within ARM. I know that there is a big new project looking to significantly expand the range of device tree and improve how things are done. I know that because it's my new project in Linaro. I'm going to be running it. In fact, just for extra hilarity, we started spinning up that project last week while I was here at DebConf. So watch this space. There will be a whole slew of cool new things coming in that area. Does anybody else have a comment or a question? We have another 15 minutes or so. Stand up for video.
So we saw about the laptop over there. We saw about the server setup. Is there anything, reasonably priced with S8, something like 4 or 8 core and 16 gig of RAM, so something like a development machine?
Absolutely. I can actually recommend the Macchiato bin. I've spoken about it before. It's available. It's a mini ITX board that comes now in 2 flavors, what they call the single shot or the double shot. The upstreaming of the EFI support for that, I think, has finally finished literally in the last few weeks. It still ships with U-boot, which some people might be happy with. I'm not. Let's not have that argument right now. But you can definitely run it as a real computer. It has a PCI slot that, in the best traditions of ARM hardware, has a couple of quirks, but does work. So, for example, my own Macchiato at home, I have an NVIDIA graphics card plugged in. On release day, as Andy was saying, we actually did a bare metal install with that machine. Using UEFI, we plug in a USB stick, and it just worked. DI worked, we ran it. It is my own workhorse machine at home when I'm doing porting work and, say, testing of EFI things and whatever. That is the machine I'm using every day.
And the price tag for those?
Price tag for that, I believe, I'm probably out of date on this. It's about $450 for, it's a mini ITX board, and that, I think, comes with, it will take 16 gig of RAM. It's a quad-core Cortex A72. It has more networking on it than any sane person would ever want.
Couple of 10 gig ports, that sort of thing.
It's genuinely a nice little machine. It's only a little machine. Again, there's a bit of a hole from that up to the 96-core server I was talking about. I have seen there's another thing that the Solid Run people are working on, which is a 16-core A72 machine. I don't know if it's actually available yet. It will probably look quite similar in terms of how it works, but I'm guessing it's probably going to be a bigger board. I genuinely don't know. I haven't had a chance to play with one yet.
When do we drop ARM-EL?
We may never drop ARM-EL. There are a lot of people who need it. Unlike certain of our other old 32-bit ports in Debian, there are people actually working on it, and it is supportable, in my opinion. I know we talked about maybe dropping it before Buster. I was convinced otherwise, so I'm happy enough. I'm not doing much work for it. As I said, I did a rebuild for ARM-EL and found that actually, apart from missing Go, which some people might not care about, it was broadly comparable with ARM-HF in terms of support. So it's good enough, I think. Any more questions or comments?
With the sysadmin hat, the DSA, has a slightly concern on the disks. On UBC machines, the nodes, there seem to be some troubles there. Not exactly sure if it's lack of RAM on the VM or it's something we need to have a look.
Background for everybody else is we have, since last DebConf, I organised 3 Synquator machines that went out to UBC to be hosted there. And we're using those for building both ARM64, all of ARM64, ARM-EL, ARM-HF, I believe. They're reasonable machines, but they're not fast machines. That's 24 cores of Cortex-A53. We have seen a problem with one of the machines, as I understand, where there's a worry about one of the SSDs that's in there. I think
a couple of them.
Okay, it's the first I've heard. I've only heard that one of the machines struggling. Luca was meant to be just swapping around the SSDs and to make sure that wasn't the problem. Last I heard, that hadn't happened yet, so I genuinely don't know if there's a real problem.
Something to look at.
Sure. Okay. Thankfully, we're now at the stage where we have a reasonably wide range of hardware available. Say 2 or 3 years ago, it was very much we were begging to get anything at all from various vendors because we couldn't buy things. We now genuinely can buy real machines, and that's a good thing. You know, the ARM64 server ecosystem is actually starting to take off.
Oh, I just wanted to comment that the cross-compiling support for Debian has just gotten better and better and better, and so even if you don't have ARM hardware, it's getting easier and easier to actually cross-build stuff for ARM, which makes development cycles go a lot faster.
Yeah, we still do not want to be using cross-building for official builds. And again, we've had this conversation lots of times over the years. But it's a good option if you need to actually go and debug things. QEMU and whatever are really, really very good for emulating.
Cross-building, well, not directly cross-building, but what will we do for the 32-bit platforms when resources for building are not enough anymore?
That's exactly it. So we will continue to have a range of ARM64 machines that can run 32-bit builds for at least for the foreseeable future. But 5 or 10 years from now, we might not, and we'll have to revisit this.
So, but we are not planning to use the ARM64 cross-compiler to ARM32 to build our native packages.
No, not at all.
Okay. So we will be limited, for example, when we want to do expensive optimizations.
Possibly, yes. It's a good question. So, yeah, Docker's talking about there are places where newer and newer compilers are coming up with really expensive optimizations that do mean you need lots of memory and lots of CPU to be able to do that. I don't know. When is that actually going to start happening? Okay.
I mean, try to build the archive with -FLTO and see how far you get.
Okay.
I mean, it's nothing experimental, So SUSE is doing that now by default. I'm not sure about their 32-bit platforms.
Okay, sure.
But we are getting to these.
Sure.
And I think there are more memory-intensive compilers like the Haskell one. Yeah, so
Sure.
we will see these issues.
Okay, so my worry doesn't tend to be the compiler itself. My worry so far is just like we've seen on other platforms, it's link time that really hurts. We have a problem today on all of our 32-bit architectures that actually linking a browser is approximately impossible because they want all of the memory in the world. That is a general problem we're going to have to solve across all our architectures, I think. We may get to the stage, yes, where we have to use 64-bit platforms to build some of our 32-bit binaries. That's a really awkward thing for us to get to. It's something we're going to have to talk about, I can see. So, Andy, do you have a...
No, I was just going
okay.
I was just going to raise the we can't build Firefox for i386 on an i386.
Sure. So, of course, we have a slightly different setup in the ARM world that you don't just pass -M32 or -M64 like you might do with multilib on an x86 machine. That has been a deliberate design choice so far. I don't know if it's going to be the right answer forever. I know our the ARM toolchains people, for example, are very happy to keep them separate because they are two entirely different platforms, significantly more different than the x86 platforms.
In that vein, I'm wondering, would building on a chroot on an ARM64 machine, which has a wider range of memory running on a 64-bit kernel, would that solve or at least work around that problem?
It will mitigate.
Other ones.
Sure, it'll mitigate in that we'll be able to run a 32-bit binary that can have 4 gigs of address space totally, or as close as possible to that. But you will still be limited in that your process will be 32-bit and therefore cannot address more than 4 gig. Please God, let's not go back to segmented memory and stuff. You know. Now, the flip side, as you say, is that we will then get back to if you have problems with alignment or other fix-ups that you need, you won't get that if you're running on a 64-bit kernel. The ARM64 kernel explicitly does no fix-ups of alignment and whatever. It expects your code to be correct. I appreciate that's an odd concept, but it's a deliberate design decision. So we might have to, as I said here, talking about performance versus fix-ups, it might also be a memory size versus the fix-ups choice. It's complicated. I guess I should start wrapping up really, unless there's any more points to make. We are always looking for more porting effort. Genuinely, especially if you're looking to carry on using ARM-EL for your projects, please show up, tell us what you're doing, and chip in. We are in #Debian-ARM or usual place, irc.debian.org, which is our FTC. We tend to be a fairly friendly bunch, I think. There's lots and lots of knowledgeable people around. Usual rules in IRC apply. Don't ask a question and then go away after 5 minutes if nobody's answered. Ask the question and stay around and give people a chance to answer. It's amazing how often people make this mistake. They turn up at 3 in the morning, say, like European time, because they're on a different time zone. Nobody answers immediately, so they assume nobody's around. Nothing could be further from the truth. Also, there's the Debian-ARM mailing list where we talk about lots and lots of this type of issue. If you have any questions, again, if you want to contribute, please turn up, join in. So thanks to, obviously, I work for both of these groups, ARM and Linaro, but definitely thanks to all the community. There's been a lot of work gone in the Buster cycle, as always, and I'm sure there'll be plenty more coming. We still have another 5 or so minutes if anybody wants to talk about anything. I just wanted to make sure I'd stated those as well.
I guess I'll just mention there are some ARM-related talks later today in the afternoon. There's what was it, the Raspberry Scape something about the Raspberry Pi, and then I have a talk just about what I do to enable a new board in Debian, just kind of some step-by-step, some tricks, things like that.
Sure. We have made great strides over the last few years on enabling more of the Debian infrastructure on ARM. So the Debian CI folks are starting to do things with ARM64 as well. I have several outstanding actions to help set them up with more. We want to have things running on ARM64 from Sala CI as well, because obviously, why wouldn't you? We have server platforms available and ready to go. Now that we have, cloud platforms like Amazon making hardware available as well, there is genuinely, no excuse now for not having everything working across architectures. We're not saying you have to. Obviously, it's entirely up to you. But now there are no excuses for not testing on ARM, apart from you don't want to. So, with that, thank you everybody for coming. I hope that was useful. Again, as I said, I will get a summary out to the mailing list later. I'm around for the rest of the week, and obviously, talk to me, talk to the other folks, and we'll see what we can do to help. Thank you.